this episode of Mr. Lehman's Knowledge Explosion, I simply want to review the ideas of perimeter and area, and of only three basic shapes: your rectangle, your triangle, and your circle. So let's start by getting the formulas written down for these three shapes. The perimeter of a rectangle is simply the total distance around the outside of the figure. So since you have a width and a length, but you have two of each of those, we would say the perimeter is two of those lengths plus two of those widths. And the area is equal to the length times the width. Now in a triangle, you have three sides, but they don't always have to be the same three sides. As you can see, I have three different triangles drawn completely different. So usually for perimeter, we say, well, you have side A, you have side B, and you have side C. So the perimeter is simply A plus B plus C. The area is 1/2 the base times the height. But we do need to be clear on what the height is. The height has to go from one vertex directly across the other side to make a right angle. So in this first triangle, the height would be here. In the second triangle, the height is actually one of the sides, because from this vertex straight down in a right triangle makes that right angle, so the height is one of the sides. And in fact, if you have an obtuse triangle like this third triangle, the height isn't even inside the triangle. Again, height simply means from a vertex straight down making a 90 degree. So in an obtuse triangle, we pretend or assume like this was extended a little bit, and this would be the height. So be careful when you're doing the area of a triangle that you understand what the height is actually considered. In a circle, we see the letter C, which stands for perimeter of a circle, but we call it the circumference. That's why we use C. So the circumference of a circle is simply pi times the diameter, and the area of a circle is pi times the radius squared. So remember, those two things mean this: the diameter is from one point on the circle through the center of the circle to the other side. This would be a diameter, but a radius goes from the center of the circle to a point on the circle, and that's what we call the radius. So make sure you know these formulas. I'm sure you've seen them before. Let's do a couple examples just to make sure we can use them. So example number 1 says the radius of circle is 6 centimeters. Find the circumference and area in exact terms. That means I'm going to leave pi in my answer, just like I leave square roots in my answer when we find the distance. So the circumference is pi times the diameter. If the radius of this circle is 6, that means the diameter is 12, because it's going to be another radius for a total of diameter of 12. So that means pi times a diameter of 12, which means in exact terms is just 12 pi. If I want to find the area, that would be pi times the radius squared, or pi times 6 squared, which is 36 pi. So in exact terms means we're going to leave it as 36 pi and not use 3.14 to round it. So make sure you understand what exact terms means. Number 2 says find the area of a triangle defined by the points D13, E83, and F47. The first thing I would do here is make a rough sketch. So if this is my point 0, 0 over here, 1, 1, 2, 3, then I have 8, 3, so 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, and then 4, 7, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So I make a rough sketch of my triangle using those points. So this would be D, E, and F. Well, remember, the area of a triangle is simply 1/2 the length of the base times the height. So I might have to use my distance formula to find some things, but what I notice is that 8, 3 and 1, 3 makes a horizontal line, which I could just count. So the distance from 1 to 8 would be 1 minus 8, or negative 7. That doesn't make sense, so it's just an absolute value of 7. So my base is 7, so it's going to be 1/2 the base of 7 times the height. Now the height, remember, has to go from the vertex drawn to the base at a 90 degree angle. So that would be from this vertex straight down at a 90 degree angle. So since we're going in the y direction, we want to look at our y coordinates. The y coordinate of my top point F was 7, and the y coordinate of my bottom line was 3. So I'm going a total distance of 7 to 3, or 7 minus 3, which is 4, and that's going to equal to my height. So it's going to be area equals 1/2 the base of 7 times the height of 4, which is simply 1/2 of 28, which is going to give me an area of 14 total. So even though I give it to you as coordinates, don't freak out. It's simply counting up and down, left and right, or in other words, finding the distance between 2 points for the base and the height. In example number 3, we're asked to find the area and perimeter of the triangle defined by the 3 points H, J, and K. Now I just showed you how to find the area of a triangle, so let's just focus on finding the perimeter. Again, I would start this problem by sketching it, so let's look at a little bit nicer sketch. So I like to plot my 3 points, connect those points, and create the triangle. And I understand that the perimeter is simply going to be adding up those 3 sides. The perimeter is going to be HK plus HJ plus JK. So I'm using those labels to represent the 3 sides that I need to add together. So I'm going to do the distance formula by using the sketch method. So let's find HK first. To sketch from HK, that's actually a vertical line, so I can just count that. 1, 2, 3, 4, 5, 6. So HK is 6. So I'm going to take 6 plus HJ plus JK for the perimeter. To find HJ, I will sketch over, and I will sketch down, and I'll go ahead and just count those. So I've got a distance of 1, 2, 3, 4, 5. And a distance vertically of 1, 2, 3. So to find HJ, I would take 5 squared plus 3 squared equals that HJ squared. So 25 plus 9 is equal to HJ squared. So 34 is equal to HJ squared, and that means the square root of 34 is equal to HJ. So I'm going to be adding the square root of 34 into my perimeter. And that's already as simplified as it will go. Now I'm going to do the same thing to figure out the distance from J to K. So I will sketch down, and I will sketch over, and I will count those or subtract the coordinates to find those lengths. This is a distance of 3 and a distance of 5. Now I'm going to save myself some time. That's the exact same distances that I just did, so that means that JK, when I do 5 squared plus 3 squared to equal JK squared, I'm going to get the square root of 34, which tells me that this segment and this segment are congruent. So I've got my 3 sides and their lengths, so I'm going to add these things together. Now, you can't add the square root of 34 with 6 because they're different numbers, but I can add square root of 34 with another square root of 34 because the square roots are identical. So this ends up being in exact answers 6 plus 2 square root of 34s, or 2 times the square root of 34, and this is my exact answer for the perimeter